All right, here we go. Solving quadratic equations with quadratic formula. Sort of the last resort method. When you can't factor, go with this stuff. So we're going to introduce it. We're going to talk about quadratics with rational, irrational, equal real roots, and then no real roots. See what it all looks like with this thing. So what is quadratic formula? Well, basically, when you can't factor an equation, you take your coefficients a, b, and c that we have from standard form, and we plug them into this big ugly formula, which only looks ugly. It's not that bad to work with. And we get an answer. Let's see what happens. Give her a whirl here. So here's an example. This is one that's going to give us a rational root, or so it says. So we've got a equals 5 in standard form here, b is negative 12, and c is 4. It's all from here, a, b, and c. So we fill them in. Negative b, so negative 12 will be positive 12. Plus or minus square root negative 12 squared minus 4 times 5 times 4, all divided by 2 times 5. Let's put that together. So we've got 12 plus or minus the square root of 144. Whether it's positive or negative, it'll be positive when you square it. 5 fours are 20. 4 times 20 is 80, so we're subtracting 80. Notice that this stuff has to go together and this stuff has to be squared before you can use that negative sign. Okay? Can't subtract until you multiply and exponentiate first. 2 5s are 10. All right, there's our denominator. So this is going to give us 12 plus or minus the square root of 144 minus 80 now is 64, all over 10. All right, let's keep going here. So that's going to give us 12 plus or minus the square root of 64 is 8, all over 10. So now we have to deal with this funny thing inside. So that plus or minus, what that means is do this thing twice. Once when we add it, once when we subtract it. It doesn't mean that we're going to get a positive answer and a negative answer. It means we're going to get two different answers, one when we add, one when we subtract. So we've got 12 plus 8 divided by 10, which is 20 over 10, or 2. And then we have 12 minus 8 divided by 10, which is 4 over 10, which, 10, which I think is 2/5. So we have two rational answers here, two real roots, two unique real roots. What happens when we get irrational roots? Well, let's see what's going on here. So if a is equal to 3, b is equal to negative 1, and c is equal to negative 9. Alrighty. See what we got. X equals negative b will be negative 1 is positive 1, plus or minus square root of b squared minus 4 times a times c. Now remember, these have got to be put together, and then this one before we can subtract. All divided by 2a, which is 2 times 3. So that will give us 1 plus or minus the square root of negative 1 squared is 1. And we've got to subtract 4 times 3 times 9 is 12 times 9. So that's going to be 108. And it's going to be subtract 4 times 3 times negative 9 is negative 108. So we're going to have plus 108. So notice that we're subtracting a negative answer, which gives us a positive. All right, all over 6. So this is going to give us 1 plus or minus square root of 109 divided by 6. Now 109 is not a perfect square. So there are lots of things you could do to simplify that and keep exact values, but for this course, all we're really concerned about is that you realize that we're going to have to get two answers, one for adding and one for subtracting. So if we add them, we've got 1 plus root 109, don't even know who Adam is, all divided by 6, and we take 1 minus root 109 and divide by 6, we're going to get two answers, and those two answers should look a lot like, if you have a good handy-dandy calculator, I'm getting 1.91-ish, and I'm getting negative 1.57. So that's close to the nearest hundredth. All right, so that's how we do when we get irrational answers. Things that don't give you a perfect square under there, what do you do? What happens if we get equal real roots? Let's see what happens here. A is equal to 1, b is equal to negative 6, c is equal to 9. Let's work this out. So negative b will be negative negative 6, which is positive 6, plus or minus the square root of b squared. So negative 6 squared is positive 36, minus 4 times a times c, all over 2 times a. So this will give us 6 plus or minus the square root of 36 minus 4 times 9, 36. So 36 minus 36 all over 2, which is 6 plus or minus 0 over 2. Whether I add 0 or subtract it, I still get 6 over 2, which is 3. So you could say that you get the same answer twice. So we get equal real roots. X equals 3 or x equals 3. Yep, that's what that's all about. Okay, what if we get no real roots? That's a funny one. So let's take a look at this one. We've got a equals 2, b equals negative 3, and c equals 7. Plug away here now. So x is going to be negative b, which will be negative negative 3, or positive 3, plus or minus the square root of negative 3 squared, which is 9, minus 4 times a times c, so that's 2 times 7, all over 2 times a. It's 2 times 2. So it's 3 plus or minus the square root of 9 minus 4 times 2 times 8 is 56, all over 4. 9 subtract 56 is, by my estimation, negative 47. How can I take the square root of a negative number? I can't. So in this case, when I get a square root under the negative, I get no real roots. What's the moral of the story here? Every time you solve with quadratic equation, or quadratic formula, I should say, you've got to do it twice. Okay? So use it mostly when we get equations that don't factor. And it's the stuff under the root sign that determines the kind of answers we're going to get. So we call that the radicand, of course, if you remember from your radicals unit. If it's a perfect square, the roots are rational. If it's not a perfect square, they're irrational. If it's 0, they're identical. If it's negative, no real roots at all. Thanks.